Hola, mi clase. All right, we are doing 6.4 geometric sequences. So I can write and use both the recursive and explicit formulas for geometric sequences. So those two words of recursive and explicit should sound familiar because we did them for arithmetic sequences. So remember, an arithmetic sequence is when one term to the next is found by adding from the previous term with a common difference, right? So that was our arithmetic sequence. We're now going to do geometric sequences where one term to the next is found by multiplying the previous term by a common ratio. So that's the difference, is that it's not an adding, it is a multiplying. And instead of a common difference, it's a common ratio. So it wants to know, is the sequence an arithmetic or geometric sequence? So to check that if it's an arithmetic, we would subtract, right? Find the difference from 2 to 3. Well, that's -1. -1, I'll write it like that. And then if I do the next one, it'd be 4/3 minus 2, right? And that would get me -2/3. Well, these are not common, right? I meant to write 2/3 and I wrote 3/3. There we go. These are not the same, so it is not an arithmetic sequence, okay? Arithmetic's gone. So then we have to check a geometric sequence, which means we need to find out if the ratios are the same. So we're going to take this term and divide it by that term. So we would write 2/3, it just equals 2/3, right? Now for this, we would do 4/3 divided by 2/1, which means I'm going to go 4/3. Gosh, what's wrong with my 3's? Times 1/2, which is 4/6, which if I reduce, that is 2/3. Okay, so far we have a common ratio. That's a good sign. We would technically then have to check the rest of them. So I would need to do 8/9 divided by 4/3. That gets me 24/36. I can divide those both by 12, and I get 2/3. So there's my common ratio. And the last one would be 16/27 divided by 8/9. If I reduce that, multiply, cross, and reduce that, hint, hint, it will be 2/3. So since we have a common ratio of 2/3, this is in fact a geometric sequence. What it means is that I took 3 and I timesed it by 2/3 to get 2. And then I took 2 and I timesed it by 2/3 to get 4/3, and so on. And I timesed it by 4/3, 2/3 to get 8/9. 8/9 times 2/3 is 16/27. And to get the next term, I would do 16/27 times 2/3 to get the next term. So it says, what recursive formula describes the geometric sequence? So here's our recursive formula. A to the n, remember that, equals r, our common ratio, parentheses, a to the n minus 1 is the previous term, okay? So we're going to write this recursive formula. All right, so we have to first go find that common ratio and see if they all match. Thankfully, it told us it's geometric, so I would do 12/8 and reduce, I would get 3/2. Okay, now if we set up all the other ratios, 18/12 and 27/18 and 40.5/27, we are in fact going to get this common ratio of 3/2, okay, or 3/2. So that is our r, right? This is my little r in this form. So the recursive formula is just a to the n equals 3/2 and then a to the n minus 1. That's it. That's the recursive formula. There's nothing else for me to fill in. This is the previous term. So like if I wanted to find, what is this, 1, 2, 3, 4, 5, the 6th term, I would plug in 3/2 times 40.5 and that would be my answer. So this is an A, by the way. I know that kind of looks like a 9, but it's an A. And same with this. This is an A. These are A's. They're really bad. Sorry. All right, so what is the 10th term in this sequence? So this is the explicit formula. Okay, so a little bit different, explicit formula. So remember, we use the recursive when we want to find like the very next term. But when it asks us to find the 10th term, we're only on the 5th term. I don't want to use the recursive formula and find the next term, then do it again, do it again, do it again until I got there. So that's where the explicit formula comes in. So we already know our ratio for this, right? Our common ratio was that 3/2. This is the same numbers as the last one. Well, our first term, our a to the 1 is 8. That's this right here, okay? And then we would fill it into here. So we'd get a to the n equals 8 times 3/2 raised to the n minus 1. Okay, that's the explicit formula. So to find the 10th term, that 10 is my n. Okay, so we would go a to the 10th would be 8, 3/2, 10 minus 1, which would get me 9, right? So in our calculators, we're going to actually put a times 3/2 to the 9th. Okay, remember we have to do the exponent first. Do not just combine 8 and 3/2 together. I've been seeing some people do that. So I'm going to go 3/2 in my calculator, raised to the 9th. Remember, I'm going to leave that hideous decimal there. I'm just going to push times 8, and it will round and change. You know, we won't keep all of these decimals. It doesn't say what to round to, but this is, hopefully it will in your homework, is 307 and we'll say 1/2, okay? We'll round it to the nearest 10th. And if you want to put that in calculator and make sure you get the same thing, that'd be a good idea. So a to the 10, or the 10th term, is this. All right. So the number of subscribers to a blog doubles each week. That means times by 2. How can a trend in subscribers be modeled? In our first week, we had 5 subscribers. So we can technically write this in both the recursive, well, we can write it in our growth model, and we can write it in our explicit model, right? We know that our function, right, our initial function, this is growth, is f of x equals my first number times 2 to the x, right? That's one way we can put it. Because we know the constant ratio, it's times by 2. We know that our first spot is here, and then we would have this as our whatever week it's asking for. But because of geometric sequences, we can actually take a to the n equals, and very similarly write 5 times 2 and then n minus 1. So these are actually very similar, except instead of writing x, we would write n minus 1. And that would be helpful if we knew like the 9th week, but we wanted to find the 20th week, or the 10th week. And if we wanted to find the 85th week or whatever. So that's where that geometric sequence comes in. So we can use both of these. They both work, growth and geometric. You can see that they're very, very similar. All right, the number of people attending the annual Town International Food Festival decreased by 20%. Remember, that's 0.2 each year since the first year. Okay, this is how many attended last year. Okay. So this is a decrease. It says, how can the attendance for the first 5 years be modeled? So we know this is in fact a decrease, right? So we know that we're gonna have to take 1 minus that 0.2 to get a rate of 8/10, right? We need that. That's our common ratio. Okay, this is our rate or our common ratio. We know that it's being changed by 8/10. Okay, so we can also call this our R, all right, just like we do in our other formula. So we can write a recursive formula, and that would help us find certain information, right? But we also would then need the explicit formula for here. So it says, how can the attendance for the first 5 years be modeled? That's where the recursive formula would come in handy, right? So we would go a to the n equals, and we would just do 8/10 times a to the n minus 1. And then we would again list our initial one. Remember how we do that sometimes for our recursive formulas? So we would say it's 1,250, okay? So for the first 5 years, it's easy to use the recursive formula because it's just 1, 2, 3, 4, 5. It's not a lot. But when it says, if this trend continues, what will the attendance be in 10 years? I don't want to keep using my recursive formula. So that's where the explicit formula comes in. We know, again, that the initial is 1,250. We have our common ratio. That's our 8/10, right here. And then we're going to take an n minus 1. So again, if we're going to try to find an a to the 10, we take 1,250, 8/10, and 10 minus 1 is 9. Okay, so 0.8 to the 9th times 1,250. We are talking about attendance of people. And so we aren't sure, you know, it doesn't have to be 100%, but we could say it's about 167 or 168. This is if you consider fractional people not to work, right? Because it is 0.77. But this is if you use true rounding rules, okay? So it always kind of depends on who wrote the question and what they're kind of looking for. But either answer would work because it's not going to be an exact perfect number anyways, because of the decimal rate, okay? So recursive formula for when I kind of want the first couple of years, explicit formula for when I want way down the road, just like when we did arithmetic sequences. All right, Tara has a company stock with a steadily decreasing value over the last week. How could she write an equation to determine the value of her stock in the future if it keeps losing value at the same rate? The dollar value of her stock each day was. Okay, these are separate numbers, okay? This is my first number, okay? This is my a to the 1, okay? This is number 2, 3, 4, and 5. I'm just going to make that very clear because I feel like the last time there were commas and things that we had a hard time seeing them. So I just want to make sure it's very, very, very clear what these numbers represent, okay? So we would first have to go find our common ratio, and we need to talk about the fact that it's decreasing. So that's going to change some things, right? Excuse me for a second. All right, sorry about that. I had to answer that. I had my phone ringing. All right, so we're going to find our common ratio. I'm going to take my second term, and I'm going to divide it by my first term. I'm going to need to do it for all of them just to kind of make sure that I have the correct common ratio. I am going to use a calculator though, because I'm not going to try to figure out what these are. We are decreasing, so my ratio should be small, right? Because I'm making the numbers smaller. So for this one, I got 9/500ths, so that's less than 1, right? That makes sense. For my second one, I got basically the same thing. It's not a perfect decimal, but it's a repeating like this. And so I could say, they probably rounded these as well, so I could say 9500ths. Let's just check the next one just to kind of make sure I'm on the right track. Don't want to round incorrectly. So 882.24 divided by 928.67. Yeah, it's back to about 95. It's got a couple zeros even. So we can say our common ratio is 9500ths, okay? They're all basically 9500ths. We are talking about money, so we would probably round them anyways. So there's where the decreasing comes in. We just need to make sure that since it is decreasing, we got to make sure that our rate is, or our ratio is less than 1, because that's what's going to make it lose money. So how can we write an equation to determine the value of our stock in the future? It keeps losing the value at the same rate, the dollar value. Okay, so we can do explicit and we can do recursive, right? So recursive, I would just do a to the n equals, and then my rate, and then a to the n minus 1, and I would write that a to the 1 is my 1029. My explicit formula would be a to the n equals my first term, 1290, times this rate, and then n minus 1 as my exponent. So you can see why geometric sequences are in exponents, because we're clearly using exponents when we have our explicit formula, right? This is my explicit formula, and this is my recursive formula. All right, so again, just things to remember are to memorize those formulas. I know this is a lot. Okay, maybe make some flashcards. We've done so many different equations, decay, growth. Now we're throwing in geometric sequences. So we've got to memorize them. It's the only thing we got. So here you're going to write a recursive and an explicit formula for this sequence. Check the ratio. Okay, get as close as you can. Just like the last example, I clearly had to do a little bit of rounding to get that common ratio. You might have to for this as well. You can use a calculator. Please don't hesitate. All right, until next time, adios.